Now, continuing with our triangles, we're going to talk about two special right triangles. Now, the good thing is, on the SAT, these two diagrams are provided within the reference sheet, so you don't have to remember them. But later in my course this year, we'll talk about where these special right triangles are derived so that we have a more deeper understanding. But for now, we just want to make sure that we can read these charts. Well, the first right triangle we have is a 30, 60, 90 special right triangle. And the most simple form is if we think about x being a side length of 1, if I have this triangle, and I can draw another one, if I have a side length of 1 on the shortest leg of my right triangle, well, then 1 times the square root of 3 is just the square root of 3, and then my hypotenuse 2 times 1 is just 2. Now, we know that 1 is our shortest side length. It will be opposite the shortest angle in our triangle, which is 30 degrees, and the longest leg will be opposite the 60 degrees. So here's the most basic form, or the unit form, of this special right triangle. And then as we scale up and we make our legs longer, we could multiply by 2 or 3 or 5. We could make them any size. So for example, if I wanted x to be 3, so this leg has a side length of 3 in a 30, 60, 90 triangle, well, then the other leg would be 3 times the square root of 3. And then my hypotenuse would be 2 times 3, which equals 6. And so we can find all of the side lengths given that proportional relationship. Then we look at our 45-45 special right triangle. This is a special right triangle because the angles are equal. That means the side lengths are also congruent. So the most basic form of this right triangle is side lengths of 1. And then the hypotenuse is 1 times the square root of 2, which is just 2. But again, if we decide to scale this up and say, oh, our side lengths are 3, well, the side lengths have to be congruent, and then our hypotenuse is 3 square root of 2. So when you see triangles that might partially fit this pattern, you can use that information to your advantage in order to answer the question much more quickly and efficiently than through other means. So let's take a look at an example of how we could use this. So for the triangle that's shown here, we're given the value of sine of an angle A. So this angle here has a sine of 1/2. And what we want to do is we want to find the measure of angle C up here. Okay, well, let's think about what this really means. Again, we could think about the fact that we have a similar triangle that's smaller here. Sine is going to be the opposite over the hypotenuse. So this smaller similar triangle has a side length of 1 and a hypotenuse of 2. Well, if we think back to our other right triangle here, we have a side length of 1 and a hypotenuse of 2. Well, that means that we have a 30, 60, 90 triangle, because those are the only triangles that will have a sine of A that is a right triangle. So if we know that we have a side length of 1 and a hypotenuse of 2, we just need to figure out whether this is the 30 or the 60. And so we have to consider the side that is opposite this angle. Well, opposite this angle is the 1. And so we look back at our diagram, and the angle that is opposite the 1 is our 30-degree angle, which means that our triangle is rotated, and this is our 30-degree angle. And given that is a 30, 60, 90 right triangle, that means that angle C has to be 60 degrees. So the measure of angle C is 60 degrees. We could also, if we needed to, for the problem like this, is we can even fill in the rest of the sides of the triangle. Using that proportional relationship, if I have a side length of 5, well, that's the value for x that we have over here. So my value for x is 5. That means my other leg is 5 square root of 3. So this leg has a length of 5 times the square root of 3. And then our hypotenuse is 2 times x, our shortest leg, which means our hypotenuse has a length of 10. We didn't need those for this problem, but it's helpful to understand how we can use the special right triangle in other ways in order to identify the missing information.